Hello, in this chapter, we're going to be talking about the cost of capital. Now, the cost of capital is the percentage that it's costing a company to get funds for capital. So in other words, if you take a look at, if you recall from earlier chapters, a company has basically three ways that they get money or that they get capital, if you will, in order to expand. They can get capital from debt. They can get capital, and so from debt is you typically long-term debt or notes payable. Notes payable meaning short-term bonds, long-term debt meaning long-term bonds. So they can go to a bank and get a loan, but typically firms will issue debt. They'll issue bonds. So one source of their capital is through debt. Another source of their capital is by issuing equity. So they can issue preferred stock, which is kind of a hybrid, as you know, between common stock and bonds. A preferred stock is stock where they pay a fixed dividend, or they can issue common stock. So these are their sources of capital. So what we're going to be doing in this chapter is taking a weighted average to find out their cost of capital. Excuse me. And the cost of capital is simply a weighted average of what they're paying their common stockholders, what the common stockholders are requiring as a rate of return, what the rate is on preferred stock, and what the interest payments are on their debt. So we've calculated a weighted average, and that's the company's cost of capital. Now you'll notice here that this is bonds right here. This is preferred stock. This common equity, they're including issuing new common stock, and they're also, so that's one way for a company to obtain capital is by issuing new common stock. Another way is they can use their retained earnings. So if you think about this, the cost of a company's preferred stock is the interest rate that they're paying, or the dividends rather that they're paying. The cost of debt is the interest rate, and the cost of common equity is the required rate of return. But there really is no cost to retained earnings, right? If a company has net income, whatever they don't pay out in dividends goes over to retained earnings. So if they use the retained earnings, isn't that free money? Well, it's really not, because you have an opportunity cost associated with it. So the retained earnings still has a cost, because we could use the retained earnings for capital for the firm to grow the firm, or we could take those retained earnings, we could invest them. We could invest in other companies. Companies do invest in other companies. They purchase stock like we do. So the cost of capital, or the cost of the retained earnings, is the opportunity cost that you're losing if you use them for capital for the firm. So the cost of retained earnings then is basically the same as the cost of new stock. The only difference is when you issue new common stock, there's something called flotation costs. That's very small, usually less than 1%. But the flotation cost is simply the cost to issue the new stock, the administrative cost to have new stock issued. Of course, if you use retained earnings, you don't have any of these flotation costs, so it would be a little bit less. But anyway, so retained earnings, if you use retained earnings, it's still the cost of common equity. All right, so let's look at this formula. So the purpose of this synopsis really is to go over this formula so you understand how to work this problem. It's really a pretty easy formula. I'm going to go through it with you, though, to explain it. So the WACC is the weighted average cost of capital. This is the weighted average cost that it's costing for their capital. We also call the WACC the hurdle rate, because if your weighted average cost of capital is 9%, say, then in chapter 10, we're going to look at, or I'm sorry, this is chapter 10. In chapter 11, we're going to look at the different ways that we decide whether we're going to accept a project or not. And if a project, if our weighted average cost of capital was 9%, for example, any project that will give us a return of greater than 9%, we would accept, right? Any project that is going to give us a return that's less than 9%, we would not accept because it's less than our weighted average cost of capital. So that's why we also call the weighted average cost of capital the hurdle rate. Okay, so let me explain this real quick. The weighted average cost of capital is the weight of debt. So these W's are the weights. That's your weighted average. So let's say that a company's weight is they're issuing 30% in bonds, 50% in common stock, and that would be 20% in preferred stock. So the weights are simply the weights of each category. That's called their capital structure. So that's given. R sub D, that's the return on the debt. So the return on debt is your yield to maturity, which you calculated in chapter 7, I think, the bond chapter. So this is the yield to maturity on a bond times 1 minus the tax rate. Okay, this is the weight of preferred stock. This is the required return on preferred stock, which we're going to calculate. And then this is the weight of common stock times the required return on your common equity, which I'll show you how to calculate. You actually already know how to calculate these. You just, you'll recognize the formulas when we get to it. Okay, so we're just gonna, the rest of the slides are gonna break down each of these components, and it's gonna solve this problem for the weighted average cost of capital. Okay, so let's go here. So here's the weights, and here's the problem that we're going to be working on. So this is all the information. This company is in the 40% tax bracket. This information here is going to allow us to calculate the yield to maturity on the bonds right here. So it's telling us that they issued a 15-year 12% coupon bond, make semi-annual payments. The current price is $1,153.72. And there's no flotation costs. We're going to just eliminate those for simplicity's sake. So we're going to solve for the interest rate here. That's the yield to maturity. This is the information on the preferred stock. So this is the par value. This is what it's currently selling for, and this is it's paying a 10% dividend. All right, so this is common stock. So with the common stock, we use 3 different formulas and take the average of the 3 to get the cost of common equity. First, we're going to use that constant growth model, that constant dividend growth model. So that's this information. Next, we're going to use the capital asset pricing model. That's the one with beta in it. That's this information. And then there's another way to find out the cost of common equity. You simply take your cost of debt and you add on a premium. So we're going to take the cost of debt that we find here and just add 4% to it. And this is the capital structure. They issue 30% debt, 10% preferred stock, and 60% common stock. So those are our weights, 30, 10, and 60. Okay, so the next thing we're going to do is we're going to calculate, and here's their target capital structure. That's the weights right there. Next, we're going to calculate the cost of debt. So let's go to the next slide and calculate this after-tax cost of debt. So using the information that they gave us in the previous slide, or a couple of slides previous, the bond was selling for $1153.72. That's the present value. You have to put that in as a negative number. The future value is the par value, which is $1,000. The payment is $60. That's $1,000 times 12% divided by 2, because it's a semi-annual coupon. And N is 30. It's a 15-year bond. It's semi-annual coupon, so 15 times 2 is 30. Then you put this in your calculator. You hit compute I-Y, and you get 5%. Now you have to multiply this by 2 because the yield is annual. So the yield to maturity on this bond is 10%. So that's what we're going to put in the formula. And so the after-tax cost of debt, this section here, is the 10% yield times 1 minus the tax rate. So it's going to be 6%. So that's the first component. The second component is the cost of preferred stock. The cost of preferred is the dividend divided by the price. Okay, there's a typo. Hang on, let me go back to that information. I'm just realizing now there's a typo on that. This is, well, it's saying that it's a 10% dividend, but, okay, so you're gonna take, so let me go back to this. Okay, so it is, so you're gonna take the $10. You take the 10%, they could have just told you it's a $10 dividend, but it's 10% of $100, so that's $10. So you take $10, it's dividend divided by the price. So $10 divided by $111.10 gives us a 9% return on preferred. So the required return on the preferred stock, that's the cost of preferred stock. So we're going to put that in the middle part of the formula. And that's going to be, it's the weight of preferred, which I think was 10%, times the cost of preferred, which is 9%. Next, we're going to talk about the cost of equity. So we're going to use these 3 formulas for the cost of equity and then take an average. The first one is the capital asset pricing model. Second one is the discounted dividend model. And then the third one is the whatever we found for the yield to maturity in the bonds plus the risk premium. All right, so the first thing, this is the capital asset pricing model. Here's beta, the risk premium, which is that they gave us, which is the difference between these two. Remember, the risk premium is 6% and the risk-free rate is 7%. So we end up with a cost, a required return of 14.2%. That's the first formula. The second formula is this constant growth model. So remember, it's it's going to be the last dividend that was received times 1 plus the growth rate. Okay. Oh, I forgot to mention, if you go back to when we talked in the chapter when we talked about the dividend growth model, remember we were finding the price of the stock, and the price of the stock equaled D sub 1 divided by the required rate of return minus the growth rate. So what they've done here is they've rearranged this formula. So if you have the price, you can find out what the required return is. So remember this, if you go back and look at the constant growth formula, you're solving for price. But if you rearrange the formula, you can solve for the required rate of return. So that's what they're doing here. So the required rate of return equals the next dividend you're going to receive, D sub 1, which is right here, divided by the price plus the growth rate. So we're taking this $4.39 divided by 50 plus 0.05, and we get 13.8%. All right, so that's the discounted the dividend, the discounted dividend model approach. And next we have the bond yield plus the risk premium approach. Remember, we found that the yield to maturity on the bond was 10%. So we're just going to take their bond yield and add a 4% risk premium because stocks, common equity is riskier than bonds. So we're just going to add a 4% risk premium and we get 14%. Now we're going to take the average of all 3 of these, and that'll give us our cost of equity, and that is 14%. Or here they're just taking the midpoint, but you just normally it's the same thing. Just take the average. It just so happens that you see these are all equal. You've got 14.2, 13.8, and 14. So the midpoint is 14%, but normally it happens to be the average too. But normally you take the average. Okay, we're going to assume no flotation costs. Here they're just showing you using this particular model. If you used flotation costs, they're saying, well, what if flotation costs were 15%? In other words, what if it were costing us 15% to issue new stock? Well, they would add in this model, the discounted dividend model, they would add in 1 minus the flotation costs here. And so instead of the cost being, when we calculated this before, the cost was 13.8%. So if you have to pay a 15% flotation cost, that's going to decrease the price here to $42.50, and it increases, obviously, if you're paying flotation costs, it's going to increase your cost of capital, so it brings it to 15.4%. But the flotation costs are nominal, so we don't have them in the formula. Okay, so now we can solve the formula for the weighted average cost of capital. So the first thing we did was we calculated the cost of debt. We calculated the yield to maturity on the bonds. So that was this. So we're going to take the weight of debt is 0.3 times 10% times 1 minus the tax rate, 1 minus 0.4, so 0.6, plus the weight of preferred, which is 10%, times the return on preferred, which is the required return, which is 9%, plus the weight of common equity, which is 60%, times the return on common equity, which is 14%. And so we end up with 1.8 times plus 0.9 plus 8.4. So our weighted average cost of capital is 11.1%. So you see here, they've kept the cost, the return here, the required return, they've kept it as a percentage, and they're just using a whole number basically when they put this in the calculator. You can do this if you want. Of course, this has to be decimal, and this has to be a decimal. In other words, your weights have to stay at a decimal, and this 1 minus 0.4 is 0.6. But you can use these, you can keep these as whole numbers, so to speak, or you can convert these to decimals too. It doesn't matter. You'll end up with the same answer. If you converted these to a decimal, then you would end up with 0.111, and you would just move the decimal place over 2 to convert it back to convert it to a percent. So this is how we calculate the weighted average cost of capital. And so you would it's a fairly simple formula, and it just gives us the hurdle rate, whereas a company will not accept any project that's going to if the return is less than the cost of capital, they're not going to accept a project. If a return is more than the cost of capital, then they would accept the project and go forward with it. And then they just talk about some other factors that can influence a firm's cost of capital that they can't control, like a downturn in the economy, rising interest rates, rising tax rates, and so forth. Okay, and then make sure you go over this in the book and on the slide here. Here they're just talking about how maybe you shouldn't use the average cost of capital for all of your projects, because let's say, for example, that you had your weighted average cost of capital, but you were comparing it for a project that was a really low risk project. So for example, if your cost of capital is let's go back on what we figured out, 11%. Let's just say our cost of capital is 11%. If you have a project that's a really low risk project, the return on the project might only be 9%. So if you were comparing a low risk project with your weighted average cost of capital, 9% versus 11%, you would not accept that project, right? Because it's not making you enough money. But in order to compare apples to apples, you really should ratchet your weighted average cost of capital down for a low risk project, because If you're using your weighted average cost of capital on an average project, on a project of average risk, that makes sense. But if you are using your weighted average cost of capital to compare a low risk project, you're probably going to reject all your low risk projects because they're not returning enough to meet the average cost of capital. Conversely, you would accept, if you're using your weighted average cost of capital to compare high risk projects that are going to give you a high return, you would accept all of those. So what they're saying here is that you should, if it's a high risk project, you should probably take your weighted average cost of capital and add maybe 3%. If it's a low risk project, you should take your WACC and decrease it by 3%. So you can compare apples to apples. Okay, so anyway, the purpose of this synopsis is really mainly to show you how to calculate the weighted average cost of capital. Hopefully this helps. Until next time, goodbye.